Hi, we're in chapter 2, organizing data, and we're in section 2.3. We're going to break down section 2.3 into a couple of chunks because there's a lot of information in it. Section 2.3 is an organizing quantitative data. Quantitative data is like numerical data. Okay, so I'm just going to start up with some data and we're going to analyze it by forming frequency and relative frequency distribution. And then over here, we'll draw some histograms, which are similar to bar charts, but a little bit different. So we're going to jump in, and then later we'll look through definitions or procedures more formally, but I'm going to jump in with the data here. Okay, so anytime you have a data set and you need to summarize it in a relative frequency or frequency distribution or on a graph, you need to figure out what the smallest data point is and what the largest data point is. So the smallest data point, we look at these numbers, 20 households, number of cars. So here's a household that reports they have 0 cars. That's going to be the smallest. And then over here, we have a household that has 4 cars, and that's going to be the largest. So because that's not, the numbers that are in the data set are 0, 1, 2, 3, and 4. That's not too many, so that we can represent each row here for one of those values. So we're going to use what we call a single valued frequency distribution. So each row gets one value. Okay. Now, we're going to go through this data, and we're going to take one data point at a time. We're going to tally it in this second column here. So that's concept of looking at the data one piece at a time. I call that streaming data. So we're analyzing streaming data, which allows us to sort of learn things about the data before you get to the end of the data set. So you don't have to wait until all the experiments are run or until all the cars have reported their households have reported their number of cars before you start to get a feel of what the story of the data is. Okay, so I'm going to grab each point and tally it up. So there's a 3, and I'm going to put a 1 on the row with a 3, and there's a 0 and a 1. Okay, so I'm just going to walk through, try not to make any mistakes. 1, 1, 1, 2, 0, 2, and 4. Let's stop here. About halfway through the data set. And just look at what we see. What do we, we're already beginning to learn something about the data set, right? We learned that there's a lot of households with 1 or 2 cars, and fewer households with 3 and 4, and a couple in there that have 0 cars. So we already are beginning to understand something about the data. We don't have to wait for all the households to report, so we start to understand what's going on. Okay, but let's finish it up. So we stopped at the 4, so we're going to get another 2. And then one more 2, so this is the 5th one. We cross this way. So these little packets, when we count them up later, it'll be easier to count because there'll be 5 in the little packet. Okay, and there's another 2 and a 1. Excuse me. And 2 2s, a 0, a 2, and a 4. Okay. So I hope I got that right. Let's check it out. One of the things I know is that there's 20 numbers up here. So I am going to report my frequencies by counting them up and check to make sure that I have 20. So we have 3 households with 0 cars, 5 households with 1 car, 9 households with 2 cars, 1 household with 3 cars, and 2 households with 4 cars. Okay, let's see if we got it right. That's 8, 9. Yeah, that's 20. So if you add these up, we should have that many households. Okay. And one more time, yep. 10 and 10 is 20. So this is our frequency distribution. It gives us the number of cars per household. And what do we see now, maybe that we didn't see halfway through the data? I don't know. There's a lot of cars with more households with 2 cars than 1. That we didn't see really that clearly halfway through the data, but we did see that most of the cars were most of the households had 1 or 2 cars. Okay, so here we go. Relative frequency distribution, the relative frequencies, calculated the same way for quantitative data as we did for qualitative data. So this number here is going to be the number of households with 0 cars divided by the total number of households. And lest you think I'm really smart, I'm just thinking nickels here. So if I had 3 nickels, it would be 15 cents, okay? And then that is equal to 15%. So my relative frequency, I could report as 15%, or I can report it as 0.15. So that's fine, unless you're requested to present the number as a percent, you can certainly use either the decimal or the percent. Okay, again, 5 nickels is 25 cents, so doing good here with the calculation. All right, and over here, this is going to be my total row where I total things up. And the question I have is, what number should be here? So what do you think? The total percentage should be 100%. So we can check that's 40, 85, 90, and 100%. All right, good. So this is our relative frequency distribution. What we want to do now is to build the histogram. So for the histogram, right here, we have to work with axes, and we will start with a frequency histogram. Okay, so we'll make a frequency histogram. All right, so the axes here, this one is going to be number of cars per household, number of cars in a household. And that's the horizontal axis, and we know it's going to go from 0, 1, 2, 3, and 4. And the frequencies have to span between 1 and 9, so I'm going to make them go to 10. All right, so this is numerical data, and we are building a histogram. We're going to draw bars. At this time, we're going to have the bars touch. It will reinforce the idea that, in fact, this here is a number line. And in fact, having 2 cars means you have more cars than having 1 car. So there is that concept of quantitative data that you can order it. All right, so that's why we make the bars touch. So 0, we have 3, put that right here. For 1 car, we have 5. Okay. 2 cars, we have 9. 3 cars, we have 1. And 4 cars, we have 2. So this is our frequency histogram. And if we look at this histogram, we might still want to be able to answer the same kind of questions we answered over there when we were looking at the tabled distribution. We can see here that most cars, the number of cars which is most common is 2. So the highest bar is 2, and that our number of cars range from 0 to 4. Okay, so in general, when we look at a graph like this, there are 3 characteristics that we want to be able to describe, to use to describe the graph. And they are center. This is a very important topic, these 3 characteristics. It's what we're always going to be thinking about when we look at a data set. How do we describe it? We want to describe the center. We want to describe the spread, how spread out the data is, how variable the data is. And we want to talk about this shape. So the purpose of any graphical representation of data is going to be able to make some comments about center, spread, and shape. So let's go ahead and try. So the center here, now in chapter 3, we will have numerical measures of center. Some of them you might be familiar with already. Things like means, medians, modes, those are numerical measures of center, but we're in chapter 2. So we're just trying to introduce the idea. Nonetheless, you know, the center of the data has got to be somewhere between, I don't know, maybe we can say about 2. Maybe it's a little less than 2. I'm not sure because I'm not going to sit here and take the mean, but I'm just trying to get the idea. So this is about 2. Use this wiggly line for about. And the data, well, how spread out is the data? Well, in chapter 3, we will go through numerical measures like standard deviation or range. But right now, let's just give the smallest and the largest because that gives us an idea of how things are spread out. So between 0 and 4. And the shape of this data, well, you know, it's kind of like, it's got a mode and a tail. Maybe there's not really a one word to describe it, but we at least want to be aware that to look at the shape of the data, okay? So maybe we can say one mode meaning one lump, one hump, one big piling, and then it does have tails. So I'm just going to actually say this is like a non-standard shape. And at the end of chapter 2, we will begin. We have a little, we have section, I think it's 2.5, where we discuss shapes of distribution. So right now, I'm just going to throw this up here, non-standard shape. All right. So this is your single valued frequency, single valued histogram, because each of these classes included only one number. So we're going to move on to histograms for continuous data. So the number of cars that we were presenting here, they were discrete. You either have 0 cars or 1 cars or 2 cars. A few of us have portions of cars. So this is really more, this is an example of discrete, a histogram for discrete data. And in particular, we use the single value classes. All right, so I am going to go to the notes and we're going to look at, so I'm going to share, I'm going to find the notes and then we're going to look at okay, so I'm going to